Good afternoon, Ancient Ruby. How's everybody doing? Yeah. Jim can hear me in the back, and he's in the way back. I also stood right next to where you're sitting, Jim, and I verified this is viewable, but I have sort of young eyes. Can you see it okay?
I can actually see it.
Awesome. Jim can see it. I can see it. You can hear me. I can see you. I can hear you. I'm excited. So this talk, how many people have seen my refactoring from good to great talk? Very cool. So this is not that. I gave that talk a bunch of times. Loved that talk. I'm very fond of it. But I was forced to let it leave the house, to leave the nest, and to create a new talk that I will now inflict upon you. So the good news is it's a brand new talk. So what I would like from you, even more than usual, is feedback. So this talk is not a lecture. This isn't even really a talk. This is pair programming. This is, we're going to look at some code, we're going to talk about some code, we're going to make some changes to it, and we're going to discuss those changes, we're going to discuss what we think of it. The point is not for me to just drop knowledge bombs on you, although I may drop a couple. The point is for us to have a dialogue, to have a conversation. So, because we're pairing, you must follow one of the most important rules of pairing, which is, if you don't understand something, you must be aggressive about admitting it.
I don't understand what you're saying.
Also, heckling is encouraged. Not that I needed to tell that guy. Okay. One of my metrics for talk success is how long it takes me to show code. So let's get this up there now.
You win.
Yeah. By the way, I work at Thoughtbot in Boston. Anybody listen to the podcast? Yeah. Cool. We have a podcast. You might like it. All right, so take a look at this code. So what's good about this code?
The methods are short.
Methods are short. Yeah. What's that? It's written in Vim. Yes. Absolutely. That's a damn good point. The best code is always written in Vim, I hear. Methods are short. Class is short. As you can see, it's only 6 lines.
Yeah, what's with your run number?
So I'm using something called relative number. So as I move this around, see the numbers change? My cursor is always on line 0. Now, for a while, I would tell people like, dude, no, relative number, it's no good. And it has one downside, which is like, oh, you're pairing, you're like, oh, change line 5. No, 4, 3, 2. Stop moving. And then you just go, just that. But actually, relative number is awesome. And I've now been convinced of its awesomeness. You're going to see me forget, but I'd like you to remind me. This is a new habit I'm trying to make. So every time you see me go to visual mode like this, that's a smell. There's a better way to do this. Rather than visual mode and then delete this method, well, there are other ways to do this, but I'd rather say D2J. So I can see that 2 lines below is that end because I have relative number. Or D3J. D close curly brace also works, yep. But the point is you can see how many lines away things are. So it's like if I want to drop down to user.parent, or to line 9, I could just say 9J and go down there. It's a little faster. And basically, I paired with a guy, Joe Ferris, our CTO, the other day for the first time in a while, and he had switched to relative number. And he started doing stuff, and I was like, my life is a lie. I have been doing this wrong all these years. Relative number is correct. I have been wrong. So I reversed my previous incorrect position. And everyone should try out relative number. It's just set relative number, one word. If you don't know how it works, do help relative number. Do a little RTFMing. OK. So we talked about what's good about this code. What's not as good about this code? Demeter or Demeter? Raise your hand if you think it's Demeter. Raise your hand if you think it's Demeter. It's good, right? So people that are like really seriously into etymology of words have told me it's Demeter. And so I will say Demeter if you tell me that a method takes 2 parameters. Which no one is taking me up on, therefore. I'm probably going to say Demeter, but then sometimes I'll say Demeter just to make sure to troll all of you.
Would you say it's a kilometer?
It's a kilometer?
Is it? I'm asking.
A kilometer? I don't understand.
Like, isn't that part of the same meter?
Same meter. I've lost you. I'm sorry. Yeah, all right. Yep. Oh, a kilometer. Yes. If this were a European talk, we'd say kilometer. That'd be a better local joke. OK, so. Yes, there is a Law of Demeter violation. It's on line 0. It's also on line -4. So I'm going to hit 8J to move up. Woo! Yeah. So this right here, is that a Law of Demeter violation? No? Let's clarify. So Law of Demeter says you can call certain, so let's get back to the origin. So there were a bunch of people working on this system, and it was called the Demeter system. And they realized, hey, this system actually is pretty awesome. It's a big system. We've been working on it for a long time, but you know what? It doesn't suck. That's a miracle. So they wrote a paper about it, because every time that happens, that's a minor miracle. Big system, working on it for a long time, isn't terrible. That's awesome. And so they said, we've been writing code in a certain way on this system, and it would be great if we could come up with a heuristic that we could apply to other code and say, hey, are we following the same patterns we followed on this system that we think made it easy to change? And so they wrote a paper, and they wrote this law, the Law of Demeter. I'm going to go back and forth just for the hell of it. So the Law of Demeter says you can call methods in your own class. That's fine. You can call methods on your parameters. You can't call methods on the return values of your parameters, unless they're the same type, but that's a thing we're going to worry about in a little bit. So line 0 is OK. So user is a parameter. We can call a method on our parameter. Oh, also, if we build things in our own class, if we make something ourselves, we have our own toy, we can call methods on that as well. So line 0 is not a Law of Demeter violation. This is. And it's because user returns a company, which then we call a method on. So is line 4, 3, 2, 1, 0. This is an even worse Law of Demeter violation. Now, real quick, let me get my tests for this. Yeah. I'll be running tests. It looks like this. They're fast because they're not in Rails. So how important is Law of Demeter? Well, Law of Demeter is actually kind of important. And the reason it's kind of important is because it's about duplication. So almost every programmer knows about dry, right? They know you shouldn't take something like the number of retries a user is allowed for his password and put that number 5 in a bunch of different places. They're like, I understand that. There should be a single authoritative source for the number of password retries you're allowed, or other similar pieces of data. So that's data duplication. You want to avoid that. There's also other kinds of duplication. Now, Demeter is concerned with structural duplication. So the problem with this class, as it stands now, is that user presenter knows that user, when you call company, returns something that you can call a name on. So what I'd rather have is I'd rather have user presenter be more context independent. I'd rather have it take a parameter and know that I can call certain methods on this parameter. That's a contract I'm OK with. But I don't want to know about the next level down. And the problem is the structure of my app is now encoded in this class. This class is now coupled to other pieces of my application. Now, coupling is a real pain. Now, coupling, let's define this real quick. Coupling is the degree to which components in a system rely on each other. So if component A has no coupling whatsoever to component B, no matter how much you change A, you will never break B. If they're coupled at all, there may be some changes you can make to A that break B. Now, this is sort of the source of almost all the heartache in programming. Because if everything were decoupled, you could always make local changes. One of the hardest things is changing a system that's coupled and understanding how these changes will ripple out across the system. So much of programming is about managing that concern. Now, Demeter says, be careful about letting this structural duplication leak out in the system. By the way, some coupling is necessary, right? If everything in the system were totally decoupled, nothing could ever talk to each other. And that wouldn't really make much sense. You could never build a system out of small pieces and build it up. So some coupling is going to be necessary, but there are different kinds of coupling. And we want to have the lowest form of coupling. So I wrote a blog post about this. You can check it out. It's called Types of Coupling. It's on the Thoughtbot blog. It's a disappointing Google search for some people. Yeah, so when I talk about Law of Demeter, how many people follow the Law of Demeter all the time? How many people follow it most of the time? How many people just heard about it today? Awesome, good. It's a great thing to know about. So most programmers say this about duplication. They say, yeah, I usually don't allow duplication. And then they have some sort of heuristic. And often this is pulled from a blog post, like most knowledge in the world, which is, well, if I have some knowledge, I'll duplicate it once. But then if I try to duplicate it again, that's when I will do an extraction like that. How many people have a similar heuristic? Something along those lines. OK. Here's my problem with that. I used to have the same thing, and then someone explained this to me, and suddenly I was like, it kind of makes a lot of sense. How many people do code review? How many people do code review by a pull request on GitHub? Or by diffs in general? OK, the problem is you can't see duplication on a diff. If I copy and paste an entire class and change one line and then submit a pull request, you will see a bunch of green of code that looks nice. Hey, that looks great. Who wrote that? And you'll say, yep, looks good to merge. And the only way you'll find that duplication is if you go searching through it, through the source tree. So in reality, just like the idea of like, oh, I'll go back and fix that up later, that almost never happens. Anybody play Go, the game Go? It's a really cool game. It's a really amazing game. It's the oldest game in the world. It's 5,000 years old. It has insanely simple rules, and yet the complexity and the beauty that comes out of it is incredible. You should absolutely at least get to like beginner competence with Go. It's such an amazing, fascinating game. There's a saying in Go which says, beware of going back to fix up. So it says, when you're playing in an area, you should just leave it in a good state. You shouldn't think, well, there's some trouble there, but I'm going to come back to fix it up. And I think you should follow that maxim in your code as well. Don't even duplicate once. It's so easy to miss that next duplication when you're coming back to it later. So Demeter is about duplication. If you follow it, you will avoid the structural duplication. I suggest you follow it just about all the time, when possible. And if you can't follow it, you should ask yourself why. Now, I noticed something interesting, which is when programmers are new, they care a lot about duplication because they've read about things like dry, and people have told things like that. So their level of care about duplication is about here. And then as programmers get more experienced, they develop a more nuanced view about duplication. And I think this is a good thing. Nuance is important. There are very few rules in programming that are laws, things you should always do. I think that if there is anything like that, it's duplication, though. I see as intermediate programmers have done it and gotten away with it a few times. And so you start to think, well, yeah, it's kind of bad, but I understand it, and I'm going to kind of ignore it. And then I've noticed with the better programmers, they start to care about it a lot more. And I think of it as a habit. Now, Kent Beck, have people heard of Kent Beck? Kent Beck says he thinks he is something along the lines of, I think I'm a decent programmer with excellent habits. And I think there's something really powerful in that. Really good code comes out of really good habits. You don't have to be a genius, but you have to be really disciplined. And caring about duplication, I think, is part of that discipline. So I told you, some of you learned about Demeter today. Some of you knew about it before, but maybe you weren't totally clear about how it works. Don't worry so much about the definition of Demeter. Worry about the duplication. And here's a good way to look for the duplication. Here are my tests for this same file. So this first test is for a test. This test and method does not violate Demeter. Notice how it's very flat. We've got a user stub. It has a method stub on it. This is using ancient mock, by the way. This test looks good to me. This test tests a method that violates Demeter. And here's your clue. We build a company, and then we stick that company in a different stub, and then we pass that in there. There's your clue, even if you don't know what Demeter is. When you find yourself reaching for nested stubs like this, it should send alarm bells going off. It should be a smell that you should pay attention to. By the way, code smell is a term worth knowing. So code smell is something that indicates there may be a problem. It does not indicate that there is a problem. I sometimes will note code smells and ignore them, because sometimes the cure is worse than the disease. So here's parent company name, which violates it even worse, and predictably, the setup is even worse. Do you see how ugly this is getting? This is your test talking to you. This is my test talking to me and saying, hey, you're making an example of LOD violations. By the way, this is not how you fix it. Stub chain. This does not fix the problem. Now, people like to say, oh, stubs suck because they're brittle. When I change my code, I have to change my stubs. Well, part of that is people encoding the structure of their application into their stubs, which is exactly what's happening here. Yes, when I change the way that users and companies and parent companies are associated, maybe flip them around or make one optional, I'm going to have to come back and update these stubs because they're ugly, because they are encoding the content of the application. And stub chain's no good either. So someone I saw a tweet that was like, we should alias stub chain to Law of Demeter violator, which is pretty awesome. Let's look at, so this is how you don't, this is how it's not dry. Let's look at another example of how to not fix this. A lot of people like lets. Got the RSpec guys here. He's going to punch me in the face. This is going to be awesome. A lot of people like lets. This code looks much cleaner, right? If I were looking at this screen, I'd be like, oh yeah, those tests are pretty awesome, nice and flat. So on Thoughtbot, we have a style guide, and the style guide says, prefer to not use let or subject or its. And there's a couple reasons. So this test seems better at a superficial level within the body of the it blocks, but it still has the same duplication up here. These lines still encode the structure of the application. They're just slightly more subtle about it, and they make the rest of the test look a little bit better. But there are a couple problems here. Here's the first reason we don't use lets. The first reason is that they create something called a mystery guest. Quick, without looking, what is user? Ha, you don't know. That's a mystery guest. It's an object that has shown up in our verification or exercise steps that was not created during the setup phase. So let's obscure that setup phase, or they make it happen basically implicitly as part of this exercise step. So when I refer to user here, it's calling those lets and doing my setup implicitly. I prefer my tests to look more flat and to have an explicit setup step. Second problem is these tests are going to be kind of fragile because it's creating a complicated fixture for every step. I bet a lot of you have had this situation where you have, so by the way, this is known as a standard fixture. It's not a shared fixture. A shared fixture is where the same tests, or multiple tests will use the exact same fixture. This is called a standard fixture, which is like, this is the fixture for everything, and everything grabs a copy of it. But standard fixtures have their own problem, and one is that they tend to be fragile. So I imagine all of you have the experience of coming in and saying, well, we just need to add one more test. Oh, but we need a user that doesn't have a company. So let's start writing that, right? So I want, when we have company name, I want to return a different thing. So we'll say it returns a default when it has no company. And I get to here, and I'm like, okay, what am I going to do? Well, user already has a company, therefore, let me destroy the company, right? That seems awesome, right? Who here likes slow tests? Yeah, exactly. So because we define the standard fixture, we've made it harder to add new tests. We've made that fixture is fragile, and it's going to be slow. We're going to have performance concerns. We're building more data than we need to. In this case, these are very lightweight stubs, but a lot of times they are not. Now, there's another concept that I've sort of stumbled upon recently, which I really like. Has people heard of the Openclosed principle? Good, okay. So have you heard of Bob Martin and his solid rules, solid code? Yep. Okay, so O is the open-close principle. The O in solid is open-close principle. And what does it mean? I'm going to give you the formal definition that sounds confusing first. It says classes should be open to extension but closed to modification. What does that mean? It means it should be possible to add new behavior to a system without changing existing classes. And the primary way you can do that is by injecting dependencies. Right? So if your class takes an outside dependency, I can write a new class that performs differently, feed that into the existing class, and get new behavior out of that class without changing the code in there. And that's a nice benefit because every time you change a class, you might break it. Right? We're all smart people, we try our best, but sometimes you get in there and you muck it up. So open-close principle says it's better if you don't have to actually change the class. It's open to extend it, but it's closed for modification. We don't want to actually change the code. We'd rather add methods or inject dependencies. I'm not the first person to think of this, but I've started considering the open-close principle of tests. I would like it if once I've written a test, I never had to edit it again. Part of my motivation for that is because it's hard to ensure I still have good test coverage. If I break 10 tests, I can go through and fix them, and I'm going to do it pretty carefully. But it's hard for me to verify, yes, everything that I used to test is still tested, and these tests are correct. That's tricky. It's a pain. And I would like to avoid things that are tricky because I want to have good habits. This standard fixture approach violates the open-close principle for tests. it makes it really likely that I'm going to break existing tests when I need to edit these lets. So, yeah?
Why didn't you just use the context for the when and put the overriding when inside of it? I mean, that would be the way that I would normally do it.
That's reasonable. Yeah, that's reasonable refactoring. That would be a good thing to do. I still think it has the same problem of the standard fixture. I still have some standard stuff up top. Yeah, other questions? I was like, I'm not going to lecture you, but then I lectured you for 20 minutes. Let's have some questions.
What did you say was your
Thanks.
What did you say was your saying at ThoughtBot about this?
About which one?
You said we have a saying at ThoughtBot.
Oh, he asked what do we say at ThoughtBot about this, which is we have a style guide which talks about general principles for how we implement things, and it says don't use let.
Then, could you show us an example of not using let?
Oh, absolutely. I would love to show you an example of not using let. So let's go back to the tests that I prefer. Here. There we go. This is an example of not using let. Notice that each test builds up exactly what it needs inside itself. Now these tests still have a problem, so let's fix that problem. The problem is we're still encoding the value. So let's go ahead and we're encoding the structure of the app. Let's fix the Law of Demeter violation and see what happens to the tests. Okay? So we'll come in here, company name rather than this. We'll say we've delegated that from the user. This is easy to do. There's a delegate macro in ActiveSupport, or there are very lightweight methods you can just throw right on user. I do this frequently and happily. I've never been like, oh, I shouldn't have used delegation. I'm always like, oh, nice, we just delegated that. Never have I gone back and been like upset about this thing is delegating. So we'll say user defines company name now. We'll rerun our tests. We have a break, which is in the test for company name. We can now get rid of this company stub. And I can actually get rid of the company entirely and say company corp. And we're back to green. Notice how simple this one is. It looks like this one. And that's because now neither violate Law of Demeter. Notice how flat it is. Notice how it builds everything it needs inside itself. Notice how it's going to be very hard for this test to break. Let's do one more. Let's do maybe more than one more. Parent company name. This is the ugly one. Let's say we define, let's do this. Let's define parent company name right on user. Now we're delegating through sort of two levels. That's okay. We'll talk about that in a second. We got some breakage. Let's see how much, let's get rid of stub chain for now. Whoops. Did you see what I just did there? D7J. Oh, yeah. Yep, damn it. This is going to take some work. Okay, so let's start by changing just the stub. I want to change as little as possible to get my test screen. So that was my one nitpick with Andy's talk, which was amazing, by the way. Awesome talk, dude. And he admitted this. He admitted what he was doing, which is he had long cycles from red to green. He also refactored in the red. So when I do refactorings, first of all, I never refactor in the red. Never. I mean, I try really hard not to. I'm on video, so like my coworkers can use this against me if I don't put the caveats in there. No, I try to be Kent Beck. I try to have excellent habits. And this is one of the nice things this is one of those things that pairing is great for, is getting your person, this test is red, and you're like, oh yeah, all right. So I try to never refactor in the red, and I also try to keep my cycles really, really short. You know why? Because broken tests suck. When my tests are broken, I am sad. I feel bad, and I also don't know if the world is going to be okay. I like to keep that time period as short as possible. So I actually have a heuristic that I pay attention to, which is what's the smallest change I can make that will get me back to green quickly. This is another thing I picked up from programmers that are stronger than I am. So I sent a copy of one of my talks, again, to our CTO, and was like, hey, what do you think? And he mentioned 3 times in the talk, he goes, you can refactor in smaller steps here, and here, and here. And I was like, I've never even thought to optimize for that. But once I started thinking about it, my refactoring got better. So you should think about refactoring as being an activity that you could stop at any time and commit it, and push it up. So think about small steps. And you'll be happy too, because you'll be green, and you'll be red for a little while, and that's okay, and you're green again. And like that, going back to green feels good. It makes programming more fun. So try to make those loops small. You could see the single bead of sweat on Andy's face when he had that 5-minute thing where he's trying to get back to green. And he's made like 2 or 3 classes and 2 or 3 methods, and it's like, and he's practiced the heck out of that talk, obviously. He knew it was going to work, but in the real world, you're kind of flailing, right? You're like, I don't know if this is a good refactoring. You throw away refactorings, that's okay. They don't always have to work. So try to keep them small, and then you only have to throw away a little. Okay, so the quickest way to make this work, I'm going to leave those stubs up there, and I'm just going to change, add the parent company name to here, and it should be Consolidated Holdings, and then back to green. And now I can refactor, and I can say D4K, yes. Oh, what did I get? I killed the it. All right, so I got to say, I'll be here, and I'll say D3K. Yeah, there it is. Nice. Okay, small steps, short red cycles. Okay, so now, so look at these tests instead. Look at my test. Now look back to yours. Sadly, your specs violate Law of Demeter. I'm on a stage. Okay. These tests, I think, follow the Openclosed principle. We've cleaned up the Law of Demeter. I'm now happy with how this looks. One thing I've been doing a lot lately is paying more attention to my tests. When my tests suck, it's probably because my code sucks. Yes?
Question.
Yes.
I'm not super familiar with the built-in RSpec.
Okay.
Expectations.
Yep.
Does this stub actually set an expectation on that method?
It does not set an expectation, no.
So those specs would run whether or not we had oh, never mind. Yes. Okay.
Yep. Yeah, so these won't complain if I don't call the method. They'll just be like, yeah, whatever, no big deal. Yeah, that's a good question. Yeah?
Would you consider replacing those stubs with actually instances of the real thing, even if they're non-persistent? Because I worry like that if you haven't thoroughly tested that, then you're setting yourself up for a different kind of brittleness.
Yep, so you said that pretty loud. So he's saying, would I consider replacing these user stubs with real instances of user? Yes, sometimes I would. I reach for stubs actually a fair amount. I like how lightweight they are, I like how fast they are, and I like that they decouple me from actually even really needing a user that responds to these methods. And secret time, I don't actually have a user that responds to those methods. There actually isn't even a user class. So and that's a good thing. So this class, user presenter, doesn't even know that there isn't a user. Coupling, reduced. This user presenter is decoupled from the idea that there's an actual user that responds to actual methods. That's what stubs get you. So yes, sometimes it's nice to integrate with real classes. And if these stubs got really hairy to create, I might consider pulling a real thing in there. The problem is, so like how would I create a real user? Well, I'd probably use a factory. That goes back to standard fixtures, right? Think about, how many people use factory girl? So think about, have you changed the factory and then had like 40 test break? It's because it's a standard fixture. It's because you effectively have global data that you're feeding into all your tests. So sometimes I do. Typically, one place I often don't use stubs is in view specs, which I'm going to talk about. I use view specs. Isn't that going to blow your mind? So views, because we're an MVC, ask a lot of questions, right? What's your name? What's your date of birth? What's your city? What's your town? What's your state? What's your whatever? You can make a stub that just answers all those questions, but like, why would you? It's kind of a lot of there's a lot of messages to program in there. And now, usually that's a smell, right? I'd be like, oh, why does this stub need to answer 10 questions? Something is wrong with my code. I think that's true, except in views. In views, I think it's OK. It's not a smell, because views are going to do a lot of asking because we use MVC. MVC says, you pass the thing to the view that you want to display, and then the view is going to interpolate a bunch of values from that thing. It's going to ask it lots of questions. So that's not ideal. There are some drawbacks to that, but that's kind of what we signed up for. If you don't like it, switch frameworks. Other questions? OK. Oh, by the way, there's a really good post on Law of Demeter. If you've read it, that's awesome. If not, you should check it out. It's written by a guy named Avdi Grimm. He's sitting right there. Long hair, white shirt. Awesome belt. Yeah. I cribbed a lot of this, whoops, there we go. I cribbed some of this for my talk. It's a really good post. It goes into a little more detail, and he says it better than I do, so check that out. Yeah, okay. What's next? Oh, so we've been working hard. I think it's important to take breaks. Let's take a break for a second. I'd like to show you something. Is it lib? Where'd this go? Oh no, where is it? We'll come back to that. No break for you. Okay, different break. Everybody stand up, please. Excellent. Just go ahead and stretch it out a little bit. Stretch whatever's tight. Oh. Everybody reach up to the air, and then we're going to go this way. Good. Keep your abs tight. Oh, don't wuss out yet. Up to the top, and then this way. Oh, feel that. Keep your abs tight. Go up. Bend over. Oh, yeah. Feel those hamstrings. Oh, man. All right, now stand up. And shake your neighbor's hand. Say, hey, how's it going? It's nice to meet you. Excellent, now sit down. Yeah, right. I watched a really good talk last night from Big RubyConf or something by the guy that wrote the Pragpog book on the healthy programmer. It was really interesting. It said, even if you exercise a lot, they've had studies that even if you exercise a lot, sitting for extended periods of time increases your mortality risk, even for people that exercise all the time. And the way you combat it is you stand up every 20 minutes. You change positions. So we've been talking about 20 minutes, so you're welcome. You're done with one for today. Okay, now I'm going to show you some code. This code is a little embarrassing. It's not exemplary code. It's real code. It's actual code that people that were trying to do smart things wrote. We tried. Sometimes we fail. Okay. This is a controller. Oh, by the way, this is Rails code now. I didn't want to have an actual Rails app embedded in my talk directory, so this is faked out Rails. You're going to see some things that look mostly like Rails, but are a little bit wonky. That's just me trying to keep the test really fast and keep this self-contained. Don't freak out. It's hard to see that top line, huh? Oh well. Not important. So this is a create action for a purchase controller. This is real stuff. This really happened. So Thoughtbot has a service we call Learn. We make screencasts and ebooks and workshops and all this stuff. It's an e-commerce site. We sell all that stuff. So we have a purchases controller, which is a user comes in and they want to buy something, so they do, and we like that. And so we create a purchase, and we want to notify KISS metrics that this purchase happened. So we track all our metrics in KISS metrics, so that we can say, how much money are we making? Is it more than before? How long until we can buy Lamborghinis? So we have a KISS metrics notifier that we create, and we pass in this KISS metric HTTP client, which is a little confusing, and then we notify it of the purchase. So this code is a little wonky. This KISS metrics HTTP client is kind of like a mystery guest in the sense that it comes from application controller. Take a look at this bad boy up there. That's my real API key, actually. I know the KISS metrics guys, we're friendly. Okay, so KISS metrics HTTP client is a method defined on application controller from which purchases controller inherits. And we have this goofiness. So up 6J, we have catter accessor, which is an ActiveSupport thing. This basically gives you adder accessor, but for class variables, but not 100% exactly the same. Go read some blog posts. It's super confusing. Because it's super confusing, I think this code could use some improvement. Shocking. So let's talk about the benefits. So what's happening here? Well, so I saw this code and I was like, what the heck is going on? Well, we're giving a slot, basically an application controller, for us to feed in a KISS metrics HTTP client, and then we call new on that. And if we look for it, client equals, we can see that it's used in a couple places. One is here. This isn't a config initializer. So when the app boots, we set the KISS metrics HTTP client to be the KISS metrics HTTP client class. Okay, that's reasonable. Also, we have this inspect support, which is a fake KISS metrics client. And we set it in there. So when we run in test mode, Our policy is for integration tests, we try not to stub anything. What we try to do for integration tests is write fakes. So check out what this fake does. So it's a fake Chrismetrics client. It has a reader of events. It has an array. And what happens is every time we call send event, we just shove it onto the array like that. And since we have a reader for it, we can go back and check. So it's an alternative implementation of a Chrismetrics HTTP client. It responds to the same methods, only all it does is record them so we can come back and look at them later. As this, in the real code, this gets a little fancier and plays back certain responses from fixture data. And it's like, OK, I know what Chrismetrics would say now if you had told me that. It just makes it easier to verify things. Yeah?
What is spec support?
Spec support is just where we stick stuff like fakes or code that's written as like test harnessing code. It's like these methods are called in test. They make the system easier to test. That's all that is. Just a convention that we follow. Other questions? OK. So what I discovered, I saw this stuff in application controller. I was confused at first. I went on a spelunking mission that required me to grep the code base. And I figured out, OK, here's what happens. When the system boots up, we feed in a real Chrismetrics HTTP client up an application controller. The subclass purchases controller knows how to get a hold of that client. It knows to feed it to the Chrismetrics notifier, which then notifies it of the purchase. In test mode, the system boots, it assigns the real client, but then it overrides that, assigns a new client, which is a fake, which means we don't have to actually integrate with Chrismetrics as an external service, and we can get at the data we've sent them easily. So what's the problem? Problem is, well, catter accessor is kind of janky. Class variables, kind of janky. You probably don't use them a lot. We certainly don't use them a lot. They're not a great solution. They're kind of weird. They have some sort of weird behavior. But even worse than that is that there's implicit knowledge in the system rather than explicit knowledge. So the implicit knowledge is what I just told you. This is what happens when it boots. This is what happens when we boot in test mode. This is why we do it. What I would and this knowledge, by the way, is spread out over 3 files. What I'd rather have is this knowledge made explicit in one place. This is something that I'm constantly shooting for. Is it a question? Or just stretching? Just stretching. This is something I'm constantly shooting for in my code, which is if I were going to hand this ball of code off to you, and I was tempted to tell you something about it, that means I screwed up. That means there's implicit knowledge that I want you to have because I know it's going to make your life easier, but I didn't encode it in the code itself. This is something I'm always trying to do. What can you tease out and make explicit that was previously implicit? This has been a really big boon for my code quality, I believe. So let's make this better. So, yeah?
How about you create in your initializer, create a class that just represents your Chrismetrics stuff. You're like Ben's Chrismetric integration class or module.
Mm-hmm.
And then put a bunch of methods on that you call to set things up with parent. That'll be your one place.
Yeah, that's a reasonable idea. And so that class decides which implementation of the client gets put in?
Right.
Yeah, I like that. What's a good name for a class that decides at runtime which class should be chosen? Factory. There's a pattern for this already. It's called a factory. Yeah, or chooser, sure. That's a good job of making something implicit explicitly wrong or explicitly confusing, just to mess with you. No, factory is an awesome name for that. It just so happens I actually already have a file named Chrismetrics client factory. It looks like this. It's pretty good so far. Whoops. Spec. It even has specs, just because I didn't want to make you watch me type this. And we're green, so I guess we're done. OK, so let's take this implicit knowledge and make it explicit right now. So what I want to say is it returns a fake client in test mode. Now, let's just say right now, let's say Rails.m should be test. I think that works. Yeah, OK. So we are in test mode. This is sort of a precondition. I'm not sure if I like this here. I think it might be reasonable to just say, we're in test mode. I'm going to assume it is. But I'm going to specify this precondition here anyway. I'm not totally sure if this is a good idea or if this is a smell. OK. So Rails.m should be test. And then I want to say fake client looks like this. It's a fake Chrismetrics client. And then if I ask the Chrismetrics client factory for a client, should be a fake client. With me so far? Fake client's that. It should be a fake client. No method error client on the factory. That's fine. I'm going to make just that error go away. I'm not going to write the implementation. Why? Because I want a short cycle before I'm green again, or at least red with a different error. I'm doing the minimum possible to get back to green. Expected nil to be a kind of fake kissmetrics client. So the default return value of that method is nil, and it's not an instance of fake kissmetrics client. So I'm just going to do this. Oh, right. This class needs a new thing, fake API key. Needs an API key. And we're back to green. I like this so far. By the way, the BIA means is looking for an instance. This wouldn't let me return just the class. It actually wants an instance, instantiated version of the class. OK, one more test. It returns a, by the way, you see what I did here about just like throwing this value in here? Andy did this earlier. This is something that I think is good habit. I've heard people call this sort of sliming. It's like the test, I know the test is going to return A or B, but in the beginning I'm going to write a test for A, and I'm just going to give it A. I want that cycle of redness as short as possible. This is a nice way to achieve that. Keeps you focused. It returns a real client when in non-test modes. OK, so whoops. Real client is the kissmetrics HTTP client. The factory client should be a real client, only this won't work because we're not in. So let's set rails.env equals non-test. Go away. Expected the fake to be real, but it wasn't. So now we'll come in here and say if rails.env.test, then that, else this. Again, that is my real API key. Back to green. Good. Now, Andy talked a little bit about what a good mock library would do about cleaning up after itself. Right now, I'm being a bad test person by not cleaning up after myself. I'm setting the Rails env, which is sneakily global data, by the way, with all the parallels that come along with global data. So let's clean it up. I want to make this a little bit better. And now that we're green, I can refactor this. So here's how I would refactor this. I would say switch to non-test mode. And let's do this in a block. And then we'll move this over here, and then we'll say rails.n equals non-test, and then yield. And we're going to ensure that we set the Rails env back to test when we're done. Whoops. Whoops. Bam. Why don't I just stub the test method? Oh, that's a good point. Then it'll clean up after itself. That's a good point. And then Andy's code will handle the cleanup afterwards. I like it. I think that's better. This is version 0.1 of the talk. I'm gonna roll that into the.
The only thing is there's multiple ways to test if you're in a test environment. So you could test rails.env equal test or rails.env.test ?
True. Isn't. So stub env. Yeah. Yeah. How about what's it called? Like this? Something like this? Isn't there one of these too? Isn't that what pain? Well, fortunately for this talk, I don't need to worry about any of that. Okay. There's a million things we could do. Okay, but we only got a minute and a half. So, questions on this? Questions on the factory? Or feedback, other awesome ideas? Is there a reason I avoid contexts? No. Sometimes I use them. Sometimes where would you put the context in? Anytime I say when I'm in an if block. Interesting. So like here? Okay, so when in test mode, it returns a thing. Yeah, I think that probably makes it a little more readable. Yeah, that's good feedback. So I like this. I like this new factor we have. And I could hack through together and show you what it's like when we rip it out of application controller and we feed it through. And so one of the nice things is, I won't actually do it because we're low on time, but I'll point out. We can get rid of all this, right? This all goes away. And right here, notice we passed in the kiss metric to HTTP client. What I discovered when I did this refactoring is that this is the only place that uses it. So we don't actually need it on the controller at all. Kiss metrics notifier itself can just go ask the client factory for the client when it starts up. And that will work. And that will notify. And then, but most importantly, as we talked about before, the most important thing is now, this is explicit. Like, anybody that reads this can understand what's going on. And I can delete several files and can get rid of the initializer that sets it up. I can pull that weird line out of the fake. And all the configuration happens in here. The tests for this are clean. Everybody's happy. I like this a lot more. This is actually this is the real refactoring I did, and I think it was a big improvement on the system.
I like putting all my API keys in initializers instead of
Scattered out. Yeah, me too. Yeah, I usually do that as well.
this whole class in an initializer.
You put this class in initializer? I wouldn't put this class in initializer. To me, this isn't part of system booting. This is something that happens at runtime. I want to make a decision as I create the kiss metrics notifier. So I'd be a little surprised to see this in the initializer, but not like shocked. I wouldn't have a heart attack. Other feedback on this refactoring?
Would you ever expect Rails environment to actually change at runtime? Because that's the only reason why you would want to actually make that decision at runtime.
That's an interesting point.
Unless that booting in the class took a while.
Unless what?
Unless it took a while to instantiate the class. Go set up some stuff, do other things.
Right, yeah. Yeah, this might be a good point, that Rails end probably would not change during runtime. But it's still, even if I'm not expecting that change, I still really value the explicitness of this. It makes it obvious that the thing that we're choosing is dependent on that Rails end, as opposed to starting having to piece that together from multiple files in multiple places.
Well, that nobody ever tests initializers.
Well, that's true, yeah. Okay, so I mentioned it earlier. We have a thing called Learn, which is kind of awesome. We launched a new service called Learn Prime, which is where you can do a monthly subscription to get everything that's on Learn, all our workshops, which are like $1,000, in-person, online, screencasts, ebooks, screencasts about refactoring. All that stuff is on there. It's pretty cheap. It's $100 a month for like $1,000 workshops, which is kind of awesome. So maybe check that out if you're interested. But talk to me either way. I love talking about this stuff, so come up, say hi, and we'll chat about code. Thank you.